Hi guys, welcome to this video where we're going to have a look at the last of the kind of rational functions that you need to be able to integrate this year. So the kind that we're going to look at in this video is should be on your screen now. Okay, so it's where it says rational functions of this type. Well, what is this talking about? Looks like we've got a function on the bottom of a fraction, so it's a rational function. Okay, but we've got the derivative of this bottom function sitting on top. So what would be an example of that actually would be something like this one down here. Let me just change the color here for a moment. So we're talking here about this kind of situation. We've got a function 2x squared plus 3x minus 1 on the bottom of this rational function, and if you derive that you get 4x plus 3. So I've got it's equal to this integral here, so the integral is equal to this natural log function here. Well, why would that be? Well, if we take a look at this, what I reckon is the answer here. Okay, if you derive that function, because it's a composite function, it would be 1 over the 2x squared plus 3x minus 1, because it's an actual log, but then times the derivative of what's inside here, which is the 4x plus 3, giving this answer here of 4x plus 3 over the 2x squared plus 3x minus 1. So if that's what happens when you derive, well, as you know, integration is the opposite process, so the integral of that rational function here should be that natural log function that's at the top here, this one right here. Okay, so if we generalize that, so if I just move over here to the right of the screen, if I have, let me just erase that annoying little dot. So if I try and generalize this, if we have y equals the natural log of some function of x, and we derive that, then it should be, well, 1 over that function of x, just like in this example over here on the left, but then times, since this is a composite function, times the derivative of this part here, this fx part, so we get f dash x, and combining the two we end up with f dash x over fx for the derivative, and applying exactly the same logic as we just talked about a moment ago. Okay, this was deriving. Man, that yellow is bright. Okay, but that means that when we integrate, we should be going from this kind of rational function down the bottom back to this natural log function. So let's have a look at a few examples where sometimes some manipulation is needed to get the derivative on the top here and of the function on the bottom. Usually that means playing around with a few constants, as we'll see if we look at an example or two. So let me change back to a color that's not going to cause us to have an epileptic fit like that yellow. So let's go to a new page. Let's go to the next page, which we don't have. So let's create a new page, and here we are. So let's take a look at this example. Let's call this example 1. Okay, so let's say we had a function like this, 4x over x squared plus 1, and we are integrating that. Well, if you look at that bottom function, I'm just going to let's say y equals that bottom function for a moment. If you derive that using just Newton's notation, because it's easy to write, we end up with 2x. Now on the top here we've got 4x, but that is simply 2 times 2x. So we can rearrange this, put 2 as a constant out the front, times 2x. Now 2 times 2x is 4x, so this is going to be equal then to the function above, because if you can multiply these two things together you get back to this, but now what we've got is this situation that we're after. So remember, note what we're after. Okay, let's make that a little easier to read. What we're after is a situation where we've got the derivative on top of a function that's on the bottom of this fraction. So we've got a function on the bottom, its derivative on top, and that will equal the natural log absolute value of that bottom function plus c. So that's the situation we've now got. We've got a function on the bottom and its derivative on top. So this should equal then 2 times the natural log absolute value of this bottom function plus c. Okay, let's take a look at a second example. Okay, what happens if we have something that's not polynomial type? Well, let's take a look at something like, let's say we had 6e to the power of 3x, and on the bottom we had e to the power of 3x minus 7. Okay, so what we want is the derivative of this bottom function on top. Well, once again, if I let y equal e to the power of 3x minus 7, if you derive that you get the same exponential function. Sorry, that should be an x. So the same exponential function times the derivative of this part here, because it's composite, which gives 3e to the power of 3x. Sorry, that minus, sorry, this is a bit of a muck up here. This part here was all wrong. Let me just try that again. Y was equal to e to the power of 3x, and the minus 7 is not part of the power. So the derivative, e to the power of 3x, take away 7 times 3. Okay, which is going to give, oh dear, I'm having a bad night, aren't I? Let's try that a third time. The derivative, e to the power of 3x times 3, and the derivative of negative 7 of course is 0. So that's going to be 3e to the power of 3x. Okay, now if you look at the top part, that is going to be, well, 6e to the power of 3x is 3e to the power of x times 2. So once again, like the example above, we can put a constant of 2 out the front and put 3e to the power of 3x here, and on the bottom leave that as it was, of course. And so what will the answer be? 2 times the natural log absolute value of e to the power of 3x minus 7 plus c. Okay, let's go to another page where I can make a bit more room. So let's create a new page and let's call this example 3 because that's what it is. And let's take a look at a trig one. Okay, so what I'm going to do is I'm going to take here question 102 from your workbook. Okay, so it's got negative 8 cos 4x on top, and on the bottom we've got 7 minus sine 4x. So let's let y be that 7 minus sine 4x. So when we derive, the derivative of 7 would be 0. Now the derivative of sine is negative cosine, and if you need to check that, remember you've got a table on page 173. So remember, we're looking at the derivative of sine. The derivative of sine is cosine. So we're going to get 0 for the derivative of 7 minus, and the derivative of sine is cosine, so minus cos 4x times 4, because it's composite, which is negative 4 cos 4x. And once again, this constant of 2 seems to be very popular coming up the front. Note it doesn't always have to be 2, and I'll do an example in a minute where it's not. Okay, so we're going to have, in this case, 2 times negative 4 cos 4x, and 7 minus sine 4x still on the bottom. And if you derive that bottom thing, we've got the top, okay, with a 2 out the whole front of the whole integral. So this will be 2 natural log absolute value of that bottom function plus c. And our last example, let's take a look at something where we don't have some sort of constant of 2 out the front. Okay, and what I'm going to do here is have a look at, where is it? One that's going to look a little strange, so we'll take a look at, say, question number 106 from your workbook. Okay, this is the integral sine of x minus pi over 4 over cosine of x minus pi over 4 dx. Right, let's do the same working as we've been doing before. Let's just check that bottom function. Let's just call that y. Don't have to call it y, you could call it u or w or something else, but we want to check its derivative. So what's the derivative of a cosine function? Derivative of a cosine function is negative sine. So this will be negative sine of x minus pi over 4 times the derivative of the inner part, which is just 1. So what we end up with is negative sine x minus pi over 4. Now if you check the top, that's basically the same as this thing over here, except for that negative sign. So what we need to do is we actually need to put negative 1 out the front, or just negative, and then put negative sine x minus pi over 4 on top. Why are we doing that? Remember, we want the derivative of this bottom function to be on top. And by putting that negative there, that is now going to mean we do have the derivative of the bottom function on top. So where can I squeeze this answer in? Okay, let me just go over here. So it'll be equal to the negative natural log absolute value of that bottom function. Okay, plus c. Alright guys, I hope that makes some sense. Remember to ask questions in class tomorrow if you're getting stuck on any of that. Alright, catch you then.